Hello friends, welcome back. Today we are going to learn about the arcs of the circle and the angles, that is inscribed angle or intercepted arc, or we are also going to learn about the subtended angles. Okay, and we'll see some of the examples based on it. So we are going to see today is arc of circle. Now all of you know what you mean by arc. Okay, suppose this is a circle with center O. Okay, and suppose I say that there are 3 points A, B and C. Okay, so now I can say AB is an arc, BC is an arc, or AC is an arc. Correct? Now we will see a combination of arc and angles. Let us see about it. Suppose this is an angle. Let me call this point D and this be point A, this point of contact, and this be point B. Correct? Then this is an arc, AB is an arc, but if you say AB, I can say this is also AB. So I will give another letter X. So this is AXB. And since it is smaller than this bigger one, I can call this as a minor arc. And so remaining is the major arc. Okay. Now can you see, actually this arc is made by this angle. Okay. So I will say this arc AXB is intercepted by angle ADB. In simple words, I will say that this angle has made this arc. That means this angle intercepted this arc. Simple way, because many students get confused between intercepted arcs and inscribed angle. Okay. Now when I say intercepted arc, arc is there. So this is an arc and this is called as intercepted arc by angle ADB. So what do you mean by the inscribed angles? Inscribed angle is nothing but this angle, but now this angle is inscribed in which arc? Now this is an angle, angle is important here. In which arc this angle is residing? That means where its starting point is. Its starting point is in the arc ADC or ADB. You can name the arcs any which way you can. So I will say that angle ADB is inscribed in arc ADB or ACB. Okay. In short, where the starting point of that angle is residing, in which arc, that in that arc that angle is said to be inscribed. This will be called as the inscribed angle and this will be called as intercepted arc. Now just tell me one thing, how many arcs can be made by an angle? Here you can see this angle has intercepted only one arc. But is it limitation? Suppose I have a circle and this is an angle. Still I will say that this angle has inscribed this arc and this arc, these two arcs. So it is not necessary that if this is an intercepted arc, not necessary this angle must be inscribed in some arc, because here the angle is starting outside the circle. It is not inscribed in any arc of the circle. So suppose I have this tangent. I have this tangent and then this angle here. So in fact this is also inscribed angle and this is also intercepted arc, even if it is a tangent. Suppose my angle is here, the starting at the center O. Still this is an intercepted arc. Correct? So not necessary that a starting point of an angle must be there on the circle itself. It can be anywhere outside. But the arc must be cut. It cannot be something like this. It cannot be something like this. Touching points, two touching points must be there. If I want two touching points, then in fact, suppose these two tangents are there. Still I will say this arc and this arcs are intercepted arcs, these two, because there are two touching points are there, angle residing outside the circle. Now let us see what you mean by the subtended angle. Very simple. This is one and same in different words. So this is the center, okay. Suppose this is a chord here, or even if you don't take chord, it's okay. Suppose this is an angle and I can say and here I'll give name A, B and D, and here it is E. So in short, you know that this is intercepted arc. ADB as an intercepted arc by two angles. Angle E is also intercepting this arc, angle C is also intercepting this arc. So I will call angle E, that is AEB, is an angle subtended by this arc. And this C, since it is starting at the center of the circle, I will say this is the central angle, or in other words, I can also call it as an angle subtended by arc ABD at center. So this arc is subtending two angles, one is at the center and one is on the periphery, that is here. But the arc is same. Arc is same, but it is subtending two angles. One is at the center C and one is here, angle E. So now let us see few important theorems about the inscribed angles, because these theorems are useful for us to solve the problems about the arcs. Now let us see the inscribed angle theorem. Just now I told you that this arc X has subtended two angles, one at center and one at here on the circumference. Correct? The inscribed angle theorem says in very simple word that this angle which is far away from this arc is half of the central angle, the angle subtended at the center. So if I say this is angle theta and if this is angle alpha, then in simple words, inscribed angle theorem says that theta is equal to half of alpha. All the angles subtended by same arc, for example, I'll show it here. Suppose I say this is an arc AB. So whatever angles this arc AB, or I'll say AXB, whatever angles this arc AXB will sustain will be congruent. For example, if I say this angle, then I can say this angle, then I can say this angle. All these angles are congruent. Why? Because all these angles are subtended by same arc. In other words, I'll tell you, if the arc is same, whatever angles are there, making those arc are congruent. Okay? The third point here is, which is very simple, but you have to remember, suppose this is circle and this is a center O and this is a diameter, then the theorem says that any angle subtended by semicircle or any angle inscribed in the semicircle. This is a semicircle. If any angle is there inscribed in semicircle, means that two points, two arms must cut the diameter. and starting point must be there in this semicircle is right angle, or in other words I can say that angle subtended by diameter is a right angle. This is very simple. Why? Because let us check here. This is an angle subtended by diameter. Diameter is the longest chord. Okay, and this is right angle. Why? I say this is right angle, or theorem say it is right angle. Simple, because what is the central angle? Central angle is 180 degrees. This angle. This is an arc which is also semicircle. It is subtending two angles. One is at the center, that is O, 180 degrees, and one is here because arc is same, this angle. And we know that theta is equal to half alpha. So half of 180 is equal to 90 degrees. So any angle inscribed in semicircle, suppose this is also an angle inscribed in semicircle. Any number of angles can be there because there are n number of points on this semicircle. So there are n number of right angles which can be inscribed in semicircle. And of course, the reverse is also true. Correct? If an inscribed angle is right angle, then it must be a semicircle. And the chord that subtend that angle is a diameter. Correct? Both the way it is true. If it is subtended by diameter, it is right angle. If it is right angle, it must be subtended by diameter, or it resides in semicircle. Actually, this is very simple. Students generally get confused in only two words: inscribed angle and intercepted arc. So just remember, intercepted arc is nothing but that arc, that curvature is cut by some angle, and inscribed angle is nothing but the angle which is staying in a particular arc. That's all. An angle subtended, same thing. Some arc is making some angle, it is called as the subtended angle. So based on this, there are several numerals or several problems are there where you will be given the measure of arc. You know that the full circle is 360 degrees. So arc may be 100 degree, 180 degrees, semicircle is 180 degrees, and so on. So they will give you the measure of arcs and they will ask you to find out the measure of angles, subtended angles, something like that. Okay, so let us see few examples first and then we will go to exercise 2.3. They say that the point O is the center of the circle. Find the value of angle ACP if angle POB is 90 degrees. Angle POB is 90 degrees. Here they are given 90 degrees and we want to find the angle ACP. Angle ACP. This angle we have to find out, theta. This angle we have to find out. Now, here also this is very important to analyze the figure. Now while analyzing the figure, what you should do I will tell you. First of all, identify the arc, identify the subtended angles and just write down, if the measurements are known, just write down the measurements. Simple thing. Now in this case, this is an arc and this is a central angle subtended by this 90 degrees. Correct? Now just check which angle is subtending this arc. This arc is subtending which other angle? Angle PAB is also subtending the same angle. One more thing I want to tell you, like before, that every time whatever you analyze, whatever you find out need not be necessary. But just while solving these examples, for the practice I am telling you, make your eyes habitual to the different arcs and different angles. Okay, even if it is necessary or not, you write down or mark on the figure whatever you find. Now here I find that this is 90 degrees and since this is a diameter, this is also 90 degree because the linear pair. If this angle is 90 degrees, then this AD P, this arc is also 90 degrees? Correct? I will write here 90 degrees. This arc is also 90 degrees. PCB is also 90 degrees. Now I can see that this arc, there are two angles subtended. First is this POA, because two endpoints on this arc as an endpoint of the arc, and then angle C. First endpoint is same at the P and second endpoint is A. That means this arc has subtended this angle and this angle also. And by inscribed angle theorem, this angle theta will be half of the central angle, because that arc is subtending central angle of 90 degrees. So what will be theta equal to? Simple, theta equal to 90 upon 2, that is 45 degrees. I have deliberately, this is very simple example, but still I deliberately took this just to show how the complicated figure may be, but still you have to understand and find out inscribed angles, common angles for the arcs. Let us see one more figure, or let us see one more example. The second example is there. This figure is shown, and what they have given. The M is the point on the chord AB. This is the chord, M is the point on the chord AB, such that PA is equal to PM. Mark it on the figure, PA is equal to PM. Now here I am going to explain you the problem on the board itself with the help of the notations or the single letters. I am not going to take names of an angles and all those things like before. Okay. So what they have asked, show that BM is equal to BQ. They have asked to show us BM is equal to BQ. This is what we have to prove. These two sides are equal. That we have to prove. Okay. Don't see visually whether they are right or wrong or whatever it is. Okay. Now, since these two sides are equal, that means this is an isosceles triangle, and so these two angles are also equal. I will call them as X. These two angles are X. Now this is a vertically opposite angle, so this will be also X. Correct? Now, can you see this? This angle is intercepting arc PB. This arc it is intercepting. But can you see this angle Q is also intercepting same arc? That means we know that any number of angles intercepting same arc are congruent. That means angle A and angle Q, this is are congruent, same. So this is also X. Now can you see in this triangle these two base angles are same, so their opposite sides must be equal. Isosceles triangle, hence it is proved. So before that you have to just analyze this. In this arc how many angles are subtended? This arc is subtending how many angles? This angle and this angle. So these two angles must be equal. This is given, these two angles are equal, this is vertically opposite angle, and so these four angles are equal. Since this is isosceles triangle, this is also an isosceles triangle. So such a simple examples are there for this topic, inscribed angle theorem and intercepted arcs or subtended angles. So based on this we are going to move to exercise 2.3, which is also very simple exercise. So let us move to 2.3. Thank you very much.